Hello mathematicians, today's lesson is called Quadratic Functions. Our learning target is I can graph quadratic functions. And so think back to our last lesson, linear and nonlinear functions. A quadratic function is a type of nonlinear functions that we'll be learning about today. Let's get started. Vocabulary. So we have two vocabulary terms today. Quadratic function is a function in which the greatest power of the variable is 2. Its graph is U-shaped, opening upward or downward. A function can be written in the form f of x equals ax squared plus bx plus c. So notice that the power here is a 2, or the exponent is a 2. It could also be written as y equals ax squared plus bx plus c. A parabola is a U-shaped graph of a quadratic function. So a parabola opening upwards is positive, and a parabola opening downward is a negative parabola. For our first example, we are graphing the most basic quadratic function, y equals x squared. So with all of these problems, we first have to create a table. Luckily, the table is already there for us. So we have our domain as x, our range is y, and we have our ordered pair, but now we have to write in the function, which is y equals x squared, or just x squared. So if we're given a domain of -2, -1, 0, 1, and 2, we should be able to come up with some ordered pairs to plot on the graph. In the function column, we'll write our domain with the function. So we're just substituting in the domain for x. Okay, so we have -2 squared all the way through 2 squared. So what is the range? If the function is -2 squared, a negative times a negative is a positive. 2 times 2 is 4. 1 times 1 is 1, 0, 1, and 4. So our ordered pairs are -2 and 4, -1 and 1, 0, 0, 1, 1, and 2, 4. Okay, let's plot those on our graph. So we have 0, 0, -2, positive 4, 1, 2, 3, 4, -1, 1, positive 1, 1, and 2, 4. 2, 4. Okay, and now we can draw our smooth curve tying those points together. And we have a parabola that opens upwards, so it is positive. Okay, let's try this next function, y equals -x squared plus 4. We already have our table set up for us, so for the function, write -x squared plus 4. And we're going to use those same values, -2, -1, 0, 1, and 2. And we can substitute in our -2 into the function. So -2 squared plus 4, -1 squared plus 4, -0 squared plus 4, -1 squared plus 4, and -2 squared plus 4. And now we can find our range. So I actually might start with the positive domain, or the positive x value. So if we have 2 squared, that's 4, but it's going to be a negative. So -4 plus 4 is 0. And then -1 plus 4 is 3. I know that 0 multiplied by 0 is 0, plus 4 is 4. Okay, for -1, where x is -1, we have a -1 times -1, all multiplied by a negative. So negative times a negative is a positive 1, times a -1, which is -1 plus 4, which is 3. And then for when x is -2, we have -2 times -2, multiplied by a -1 on the outside. So -2 times -2 is +4. Multiplied by -1 is -4. So it's -4 plus 4, which is 0. Okay, so let's write down those ordered pairs. We have -2, 0, -1, 3, 0, 4, 1, 3, and 2, 0. And now let's plot them. So -2, 0. We have 3, or -1, +3, 1, 2, 3, 0, 4, 1, 3, and 2, 0. And we can draw in our smooth curve connecting those points. And we have a parabola that opens downward, so it is negative. The function d equals 4t squared represents the distance d in feet that a race car will travel over t seconds with a constant acceleration of 8 feet per second. Graph the function, then use the graph to find out how much time it will take for the race car to travel 200 feet. So the domain, instead of x, we can just call that t, and then instead of y is d. And then the function is 4t squared. So for this type of problem, we can't have a negative distance. So for the domain and the range, we can't have negative time either. I'm going to use positive values. So starting with 0, 1, 2, 3, 4, and then I might just add on a 5 and a 6, and then substitute in t into the function. So 4 multiplied by 0 squared, 4 times 1 squared, 4 times 2 squared, 4 times 3 squared, 4 times 4 squared, 4 times 5 squared, and 4 times 6 squared. So when x is 0, the range of y is also 0. 0 times 4 is 0. 1 times 1 is 1 times 4, which is 4. And so now I'm just solving for the range using the order of operations. So 2 squared is 4. 4 times 4 is 16. 3 squared is 9. 9 times 4 is 36. 4 squared is 16. 16 times 4 is 64. 5 squared is 25. 25 times 4 is 100. 6 squared, 6 times 6 is 36. 36 times 4 is 144. So now we have our ordered pairs. 0, 0, so it goes through the origin. 1, 4, 2, 16. We've got 3, 36. 4, 64, 5, 100, and 6, 144. Okay, now we can graph the ordered pairs. So for the time, I'm just going to use a scale of 1, 2, 3, 4, 5, 6, 7, and maybe 8. And then for the distance, I think I'm going to use a scale of 20. So it'll be 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. And so I'm going to graph now. So we have 0, 0 is our first ordered pair. At 1 second, we had a range of 4, so somewhere down here. 2 was 16, so closer to 20. 3, 36, so below 40. 4, we have 64, so just above 60. 5, 100. 6, 144. So just about there. So we graphed the function. Then it says to graph to find out how much time it will take for the race car to travel 200 feet. So 200 is this line right here. So if I'm estimating, and I were to draw my curve here, I would estimate that it would be probably about 6 or 7. So between 6 and 7, but closer to 7. So about 7 seconds. The function h equals 66/100 multiplied by d squared represents the distance d in miles you can see from a height of h feet. Graph the function, then use the graph to estimate how far you can see from a hot air balloon 1,000 feet in the air. So let's start by filling in our table with the function. So it's 0.66d squared, and we can let h represent y and d represent x. So distance cannot be negative, so I'm going to use positive values for the domain. And then I was kind of given a hint here with 1,000 feet. I'm going to be using bigger numbers besides like 1, 2, and 3. I'm going to be using larger numbers than that. So I'll start with 0, but then I'm going to use larger numbers. So 10, let's try 20, 25, 30, 35, and 40. So I'm going off the chart, but that's okay. So 40. The function, let's write it down, 0.66 multiplied by 0 squared. And I'm just going to keep filling this out, substituting in the numbers for d. Squared. And then let's solve for h. So we've got 0 squared, which is 0. 0 multiplied by 0.66 is 0. So it does pass through the origin. So 10 squared is 100. So if I multiply 0.66 times 100, just moving the decimal place 2 to the right, so it's 66. And then 20 squared is 400. So I'm multiplying 400 times 0.66, which is 264. So I am using my calculator for this problem, and I give you permission to use your calculator as well. Okay, so 25 squared is 625 multiplied by 0.66 is 412.5. And then 30 squared is 30 times 30, which is 900. And then 900 multiplied by 0.66 is 594. Okay, now let's do the next. 35 times 35 is 1,225 multiplied by 0.66, which is 808.5. And then the last one, so we have 40 squared, which is 40 times 40, which is 1,600 multiplied by 0.66 is 1,056. So let's write our ordered pairs. We've got 0, 0. Got 10, 66, 20, and 264, 25, and 412.5. And then we've got 30 and 594. And then 35 and 808.5. And 40 and 1,056. Okay, so we've got our distance and our height, and we need to graph those ordered pairs. So let's use a scale of 5 for the distance, so 10 for every, so 10, 20, 30, and 40. And then we can use a scale of 100, so 200, 400 for height, 600, 800, and 1,000. Okay, so let's plot those ordered pairs now. We've got 0, 0. At 10, we've got 66. 20 is 264, so just about there. 30, or actually 25, is 412 and a half. 30 is 594, so almost 600. And then 35 is 808 and a half, so really close to 800. And then 40 is over 1,000. So let's use the graph to estimate how far you could see from a hot air balloon 1,000 feet away. So it's probably, if I were to just draw my line of best fit here, I'm guessing it'll be really close to 40, but greater than 35, so I'm guessing it'll be about 39 miles.